Hello, everyone. I am Chester44, also known as Fly, and welcome to this Let's Play of In Other Waters. Last episode, we began by, basically being some sort of AI in some sort of underwater suit with... underwater diving suit on an ocean in a planet in another system. Glies 667cc, I believe it was. And it appears to be full of life. Unfortunately, us being an AI, this is all we can really see. We have an idea of the rough geography of the place, or actually, no. Less geography, more topography. But life we can only see here as yellow dots at the moment. We can scan to see what kinds of things we've identified, and we do have some names for some of these things, thanks to the pilot currently inside of us. But that's about all we got. But we have managed to get some samples, and it seems that this one, shrill sacs, we can use to pop our way through here. Very useful. Let's move on. Something over here. Tall stalk. Some creatures target these tall stalks directly, perhaps because they keep them away from the other softer stalks nearby. Navigating these dense growths is like finding your way in a labyrinth, moving from clearing to clearing with little sense of what's ahead. We don't have much, but... let's see. Some creatures target... okay. Oh no, that's not what I wanted. I wanted this. Bubbles like huge pearls glint among the stalks. How do the tall stalks produce these strange, screeching sacs? The growth patterns of the stalks suggest a complex territorial network. Are we underestimating the complexity of these life forms? Okay, we've seen that one. But there was another one. Oh, that one we've seen. Okay, so these tall stalks actually scream and cause them to leave. Interesting. I know I saw another one coming by here. It's got it. There it is. Nope, not that one. I know I saw another. It should come back. Okay, we can gather more here. Oh, that's it. The shelled creature again. There seems to be some tolerance for the creature's scraping by the stalks. They only warn the creature if it cuts too deeply. And new species logged. Good. I'm going to call these signal stalks, for the signaling role they play in the stalk ecology. Tall, bubble-producing stalks that protect and monitor stalk colonies. A key part of the stalk network that stretches across the reef. Yeah, and I saw another one of these coming by. We can pick up a few more of these. Oh, nope, we've seen that one. And we're full up. Okay, so we can only carry 9. Noted. But I know I saw another one coming in. I want to catch it before we move forward. Just gotta wait for a minute. Come on, I know I saw you. You're gonna come back, and then we're gonna have an ID for these things. Let's see. Oh, no, I think we saw that one. There it is! Stalk Scraper. Okay. I'm naming these Stalk Scrapers, for obvious reasons. You can check my notes back at the base. A large creature with a translucent shell and jointed legs for swimming and feeding. Grazes on the membranes of reef stalks. East and west are stalks as far as the eye can see. They fade off into the silt like the towers of a miniature city. And more bubble-producing stalks. Are they sentries designed for early warnings, or last-ditch defenses of the colony's core? Another sample gathering spot, but I don't think we need anything else at the moment. This isn't a forest, but it carries the atmosphere of one, being immersed in interlocking natural processes of life and death. I mean, I guess we can use this. But let's take a look over here. Let's see. Spores from the stalks seem to be massing here in large clumps. This might be a good place to sample them. And these two boulders are covered with tiny stalks. A coating of amber fur waving in the currents. I doubt there's going to be anything too notable here, but I'll scan it. Oh! Something... There we go! These creatures aggressively pursue certain spores, but ignore others completely. Can they detect differences in the mineral content? The relationship between these creatures and the stalks is unclear, but they camouflage themselves among the amber colonies. Okay, so there was something useful there. Okay. The last line of thick stalks before the sandy plains of the central reef. That's it. We're through. This place is overwhelming. So many new species. This is the central reef. I saw on Manet's maps that the shelf flattens out here. Ripples of silt bounce sunlight back up through the water, giving it a golden glow. And the water beneath this outcrop feels cool, oceanic. Soft currents scrape sand from the rock face. I have a feeling this can go back south. Yep, a set of smooth stones sitting together in a pile. Could a creature have gathered these here? Is this a nest? Oh! Come here. I've noticed smaller, spotted variants of these creatures. Another species? Or perhaps sexual dimorphism. These might be the males. Seems to be the only one. Nothing else of note here. Oop. Have I seen that one? Yes, I have. Alright, moving on. Let's keep going. The center of the reef is flat and sandy, with few rocks to attach to the stalks struggle this. With few rocks to attach to, the stalks struggle to seed these waters. I think we found something. There it is. I see the way station ahead. So do I. A way station set up by Mine Nomura. It's seen better days, but it still functions beneath the coating of stalks. This'll be useful. This place is looking a little worse for wear. Let me see if I can find an access port. Mine never did take care of her equipment. Some things never change. Sorry, give me a sec. I'm just trying to... Got it! Okay, we should be able to access any data stored here. Just open the terminal and take a look. Terminal available. Spoofing user Dr. Mine Nomura. Last accessed, history cleared. Log download, yes, no. And it looks like we can fill up on power and oxygen. Good. Map data. Sync complete. Data released to pilot's console. Logs have been cleared. I expected that, given the secrecy Mine seems to be operating under. But the map data mentions something Mine calls the Bloom, out across the northern rift. She's been going back and forth to something there, studying it. A unique species, perhaps? Mine, what were you doing here? Why were you keeping this discovery from this world? From the world? From me? I'm talking to myself again, or to whatever you are. Sorry, I don't mean... Let's head back to the research base. I need to think. With this way station operational, we can call in the base's retrieval drone from the utility panel. This drone will be able to pick us up from any area we've got map data for. Let's head to the base. I've got a lot to figure out. Aha! Mapped region. Connecting. Drone ready. Request retrieval. Alright, I guess we're gonna have this. Okay, restarting in safe mode, resyncing with Baikal OS, downtime 4.2 hours. Okay, you can't quite see. Hey, are you back online? Yes. Pretty sharp work for a biologist, if I do say so myself. Hooking up that strange casing of yours to the base took some work. And the OS here does not play nicely with whatever you are. But you should have access to select subsystems of the stack now. Monet looks to have repurposed some of them, so not everything is functional. Comms are shot, the generator is only partially working, and one of the retrieval drones is missing. But I've booted up the dive bay's mapping systems and sample storage. The lab is also online, with analysis tools and an integrated taxonomy for logging creatures. Take a look. I've already logged the creatures we discovered on our last dive. For any logged creatures, I'll also put sample requests in their taxonomy entries. To fulfill these requests, just find and transfer the samples to the lab, then analyze them. I can use that data to add to the creature study. We need to register these species. Head down to the lab level and take a look. I'll also mark sample requests on the dive map. That way we can grab key samples for our studies while we're out in the ocean. And we are going back out soon. While you were offline, I spotted a signal. A suit transponder. You can see its location on the dive map. I want to find it. A suit transponder means a suit, and a suit means Monet. I'll need your help. That suit takes both of us to pilot it, and it's the only one I've got. Once you're done exploring the base, load into the dive map. We can head out from there. Okay. Sample store. So that's all the samples we got. Let's see. Communications. Comm signal. Signal error. Antenna damaged. Automatic repair not possible. Offsite assistance needed. Contact by call. So we can't communicate with anyone. Okay. Habitation. That must be Ellery Voss. Crew terminal. User Ellery Voss. Secure protocol oversight active. Okay, we've got file 1. Personal log 01-2216, Dr. Ellery Voss. Monet is gone, and she's left behind one hell of a mess. This base is falling apart, cannibalized to build way stations out in the ocean, the communications array sliced away, life support failing. Where did she even commandeer this research base from? There's no way Baikal would have supplied it willingly after what she did to them. What did she call me out here for? To witness her disappearance? Or did she simply want me to encounter, as she did, the impossible life of this ocean? How could it have gone ignored for hundreds of years of exploration and conquest? There are too many questions to even begin. All I can do is keep an account of what happens here, so that if I can't answer these questions, someone else might. It'll be weeks, maybe months until the next ship passes close enough to pick up my shuttle transponder. Until then, I'm alone. This place is unbelievably important. Our first contact with life beyond Earth. Something else is happening here, too. I need to know what it is. Alright. So that's the habitation. This is the diving bay. And here we've got the lab. Okay, we've got taxonomy. Animala novae, for animals. Arthropelta, jointed shells. Stalk scraper. Stalk scrapers are large, translucent-shelled creatures with a distinctive swimming motion, which feed primarily on stalk colonies. Surprisingly nimble, despite their size, stalk scrapers use some of their modified limbs to swim through the water and others to scrape away the chitinous membrane of the stalks. This is tolerated by the stalks to some degree, although they will also deploy shrill sacs to scare the scrapers away. Stalk scrapers seem to be one of the more socially active of the reef creatures, and will call to each other when grazing or when frightened. Each specimen has a unique cloud pattern on its shell. wonder how these are formed and what their significance is within communities. Okay, food sample analysis for that. Shell sample for theories. Need to complete the study for a sketch. Okay. Fungi novae. Caulodia, fungal stalks. Alright, reef stalk first. Reef stalks are fungal life forms which take the form of a series of stalks and plates anchored to rocky substrates. Their chitin exterior ranges in color from dark amber to acid yellow, leading them to resemble oversized lichens. This outer membrane is marked with slits which expand and contract, producing a distinctive hum. These slits, or pores, also allow both the release of spores by each colony and the absorption of other colonies' spores. I'm using this term for ease, but are these really seeds or something else? Both the hum and the spore exchange seem to be part of a complex communication network between individual stalk patches or colonies. However, like earth fungi, the visible part of these stalks may only be a small part of their overall mass. What networks might connect these colonies beneath the ground? Okay, spore sample analysis needed for that, root sample for that. Then we've got sing stalk. Sing stalks are towering fungal stalks that, through swaying, produce a distinctive hum or groan. Part of the stalk ecology found on the central reef, the precise role of sing stalks is particularly obscure. Their singing seems to connect with the sonic communication between stalks, as seen from the stalk's use of shrill sacs as an alarm mechanism, but what they're communicating remains unclear. Notably, sing stalks are often coated in sporing fungal growths, which release spores as the stalks sway through the water. These spores, released high up in the water column, cover a large area of the reef. There's something tree-like in the structure of the sing stalks, so much so that they give the impression of an underwater fungal forest. Strange, and yet familiar. Bark sample for that, tissue sample for that. And finally, signal stalk. Signal stalks are tall, thin, bubble-coated stalks which are often found beside other stalk colonies. Like other colloids, signal stalks have a chitin exterior, but unlike other species, they feature prominent irising pores that allow them to produce the large bubbles I have named shrill sacs. Through this, signal stalks act as the protectors of stalk colonies, their shrill sacs breaching when predators approach, resulting in a warning screech that causes nearby stalks to retract. This makes them a target for creatures which graze on the stalks, and only some colonies are able to maintain a signal stalk protector. But how do these stalks produce their bubbles? And what dictates their growth patterns? Further analysis of their physical products and structure should help. Bubble sample, tissue sample, sketch. Okay, we don't have any Plantae novae or Bacteria novae. Okay, sample analysis. We need to store things in the base to do so, which we will. Okay, medical has nothing. Base user detected, and medical assessment due. There's the generator. Running at 34% efficiency. Tidal turbines active, core stable. And observation blister. Sonar system requires crew inactive. Okay, well, we can store things in here. We need one of each of these, I think. That should do it. Okay, first up, let's analyze one of these. Lab analysis complete. Multiple taxonomy entries updated. Let's analyze each of these. Stalk spore. Taxonomy updated. Further analysis possible. And a shrill sac. Taxonomy entry updated. I can keep analyzing. Interesting that further analysis is possible. Okay, Arthropelta. Behavior. Analysis of stalk bark shows that it is chitin-based as suspected, containing glucose and high levels of polysaccharides. This makes it an ideal food source for the scrapers, but not only this, it makes stalk membrane a vital substance for lichen scraper shell formation. The more stalk membrane consumed, the larger and thicker a scraper shell will become, which explains the variance in scraper shell size and translucency. Going further, shells may also be markers of a stalk scraper's importance within the community. A larger shell means a more effective grazer, and therefore a more preferable partner. Further analysis of scraper shells is needed to continue this line of inquiry. Okay. We'll need a shell sample. And each one of these is getting something. Reef stalk behavior. Analysis of stalk spores has revealed a rich cocktail of compounds unique to each spore, some of which are previously unknown to human chemistry. This aspect of the spores and their noticeable exchange between colonies of stalks suggests that these chemical cocktails are part of an information exchange network. However, some of these spores also appear to be true spores, used for the asexual reproduction of stalk colonies, suggesting that the information-carrying spores are adapted or modified reproductive spores. Analysis also suggests that stalk colonies may possess a high level of intelligence and cognition, and that the messaging provided by the spores is nuanced and even subjectively unique to each colony. Patterns across multiple spores from a single colony even suggest a chemical signature possessed by each stalk group. Could these be thought of as stalk names? Interesting. Sing stalk has something in behavior. Analysis of the stalk bark sample has given some new insights into the sing stalks. Their entire biology is compressed into the chitin plates that surround each specimen. They're completely hollow. In fact, rather than being a single large stalk, sing stalks are actually many spirally entwined stalks, which weave together to form a pillar-like shell. The scraping of these stalks as they move against one another produces the stalk's harmonic hum, which may not be a form of communication with other colonies as first thought, and instead a kind of internal metronome, there to synchronize the movements of each individual stalk within the weave of stalks. But if the sing stalks are the bark that surrounds them, this brings with it a new question. What do sing stalks contain? Further analysis is needed. Interesting. And then we have the signal stalks. Shrill sac laboratory analysis shows that they are formed from a coating of mucus sealed around a pressurized mix of oxygen and carbon dioxide. The oxygen shows that the signal stalks are able to absorb oxygen from their surroundings, perhaps through their large pores? Meanwhile, the CO2 must be the result of a fermentation process within the stalk itself. This suggests the presence of a fungal symbiote, similar to yeast within the stalk, and the possible production of ethanol as a byproduct of this process, though a tissue sample will be necessary to confirm this. Shrill sac production, meanwhile, seems to be a precise art. The pressurization, gas mists, and size of each shrill sac can differ from stalk to stalk, meaning that warnings can be directed to particular colonies and even individual stalks if necessary. Alright. And then we have the dive map. That's the overall map. So we're here. Okay, so we are here. Signal priority. The base has detected a suit transponder at these coordinates. Could this be Monet? We'll have to head into the East Reef to find out. Sample request, reef stalks. Route. According to the map data, these caves cut back under the forest. Perhaps there are exposed roots inside. And sing stalk tissue request. Here, where strong currents batter the stalk forest, might be a good place to find exposed or damaged sing stalks. And shock scraper's shell. I saw stalk scrapers here when we crossed the forest. We should search this area for fragments of their shells. Okay, so we started... Oh, there's a fair bit. Minet's notes mention something called the Bloom across this rift, but until we have stronger propulsion, we won't be able to cross it. So there's going to be a fair bit here. So we started down here, came out this way, moved through the forest and headed on up, and then just headed all the way north to here. So it looks like we might be able to get a shell here, and we've got some things over here that we might be able to get. So it looks like we're going to try and explore around here, see if we can find any way through to these samples before we take a look down in this direction at whatever's over there. But I think we'll do that in the next episode, because this one's gone on about long enough. Learned some interesting things. Have nothing else on the terminal. Next episode, we'll move on and see if we can do some exploring and maybe find some useful things. That'll be in the next episode. So until then, I am Chester44, also known as Fly. This has been a Let's Play of In Other Waters, and I shall see you all next time.